Thank you, Abhi, and thank you to ABC for hosting this conference and allowing me to talk about this topic of automation in process control. So Sid did a good job in paving the way to this conversation and talking about how important digitalization is to the future. And as part of digitalization, automation comes right into the picture. Because if you do not automate, then you run into problems with how in the world are we going to get the data? So one of the things that Sid talked about was the reason there is a problem getting into the space was lack of data and lack of systems or older systems. And when you have those type of systems and everything written on a piece of paper, nothing can be done to step forward into automation. So it is an important topic for today, and all the companies are embarking on goals related to sustainability, related to digitalization, related to efficiency improvements. How do you get there? To get that, we need to understand where we stand, what the importance of automation is, what risks do we have if you don't take that step, and what are you going to do to be prepared and ready for the future? So, relevant, very important topic for today. So, let me first introduce myself. I know Abhi introduced me. I am Sudha, Jebadurai, and I have been with AGR for almost 25 years. Been in this world of blow molding, starting from when I wrote software for it to now being the Chief Operating Officer of the company. So have been with a lot of customers talking about what changes do we have to do and what steps do we have to take to be ready for the future. Just a quick history on AGR. AGR has been around for almost 100 years. We have been in the quality control space forever. We started off with the glass industry in the 1930s and then worked our way into various packaging, and then PET came into the space of packaging. We entered into that space and we entered into the process control world in the 2010s. So we have a long history of what quality control is, what process control is, and how we can assist the market in that regard. The agenda for today is basically talking about automation in the process control space, and if, as an industry, we are ready to embrace it and to move forward into the future. The first thing that we'll talk about is what is automation, when is it necessary, how does it relate to the PET blow molding space, take a look at a couple of cases, how it was implemented, and the last and most important question of, are we ready and prepared for what it takes to go into the future? Sid started off with a few questions, so I'm kind of going to do the same format. So if you guys can answer me, that would be interesting. So the first question is, what is automation? I'll give that to you. It's very simple. Anything that reduces human intervention and improves the process and makes it efficient is automation. It's very simple, very straightforward. Automation is all around us. It has always fascinated me because you can do so many things with it if you understand it, appreciate what it does, and actually use it well. So the first question I have for you is, have you performed math calculations manually? How long has it been since we've done math calculations manually? What actually came to the rescue? What do we use now? Come on. What do you... Calculators, right? Nobody even multiplies 2 times 3 anymore, right? We all say, okay, let me take the calculator and figure this out. So calculators came to the rescue. We don't think of it as an automation device, but it absolutely is. It reduces human intervention and does something automatically. The second question, have you done complex algorithms? Trees, okay, if this happens, then do this. If this happens, do this calculation. If this happens, what came to the rescue? Do we do that in our head? How many flowcharts have you drawn in a piece of paper and worked through your algorithms down to the chart? What came to the rescue? computers? Software algorithms, computers come to the rescue. This is a little bit more common. Have you performed any manual operations around the house? Digging a ditch, mowing the grass, whatever, fixing something. What came to the rescue? Power equipment, the various tools that you use. Do we ever think of it as automation? But they're all around us. If we can see it, recognize the value of it, and be able to move forward, it will become a major benefit. So that's just putting automation in very, very simple terms. Why do we think automation is necessary? Okay, that's fine. You can do it. Why is automation necessary? One, when you have increased volume or speed, when you have so much to do, automation comes to the rescue. Two, when you require precision and intolerance to variation, it comes to the rescue. Humans are great. We can do a lot of things. We can do new things. But consistency in what we do is not something we do perfectly. But machines can do it very consistently. Three, when you need increased efficiency, how many of us get diverted very quickly? Okay, I'm doing this, somebody comes, talks to you, you're like, okay, I forgot this, and then I do something else. When you need efficiency, then you think about automation. And when you need better quality, you think about automation. So these are all factors that you should keep in mind when you want to say, is this an application that needs to be automated? So, the terms that I want you to think about is high speed, repeated, consistent operation always calls for automation. That's fine. We are in the blow molding space. What does automation and blow molding mean? Have you heard of the same terms? High speed to satisfy customer demands. How many of us have heard tighter budgets? Oh, you're only going to have so much budget, but you need to have more output and be able to keep the efficiency and the performance good. Sustainability goals. We've all heard of it, we've talked about it. So when you talk about an industry space that talks about high speed, repeated, consistent operation, then we talk about digitalization and automation. What are the sustainability goals that we've heard? All the major companies have talked about sustainability goals, carbon emissions, RPET percentages, and things like that. So zero carbon emissions by 2040, EU directives for RPET usage. Every major company and corporation has sustainability goals. How do you accomplish these goals? We've heard of reduce, reuse, and recycle. Heard of lightweight. One of the studies shows that if you reduce 0.5 grams of reduction in the weight of a PET bottle, you can save 720 tons of CO2 per year per line. RPET, if you can recycle the whole thing and not really get any raw materials from the earth, you can save even further. So what that says is, yeah, there are steps to do it. There are these sustainability goals, but there are also these efficiency goals. How do I merge those two together to actually make progress to reach your customers, to reach your corporation's goals? And that is what we call responsible packaging. Let's just take a step back into the blow molding space. This is a dual spec, two-stage blow molding. So we get the preforms from either your own facility or you buy preforms from different sources. You can have virgin preforms, you can have RPET preforms. It all goes into one particular machine. And that machine, irrespective of the variances, is supposed to produce a consistent bottle that can go into the filler, the capper, the labeler, and the packer, and it is supposed to perform just right. What are the issues that you can run into when you have such a serial line downstream when the incoming variances are so huge? The first one, the variation of the incoming preforms itself. If you have been in the blow molding cooling space, you know as of today all the issues that you have with the in-kind preforms. Did I produce it in-house? Did I get it from somewhere else? Did I make it today? Did I make it 6 months ago? Did I store it in a humidity controlled space? Did I not store it in a humidity controlled space? Did I have a FIFO? Did I not have a FIFO? Did it rain yesterday? Was it sunny yesterday? Everything changes the preform and the bottom that you're going to make. RPET just adds to the variances. The second, the environmental conditions itself. You can have the preforms the best way. You can have it sourced from exactly the same place. Have it controlled just enough. But if it was sunny yesterday versus it's raining today, the process that you have set up for that particular blow molder is going to be different, and it will produce a different bottle. 3, the equipment performance itself. We say it's one blow molder. How many molds are inside that blow molder? It's almost that many number of machines inside the blow molder. If one valve goes bad, you could produce a different bottle for that particular mold. So there is variances in the machine itself. If you do not do maintenance on that machine well, not all molds have been replaced just right, and all maintenance have been done exactly the same, the machine is going to be different, the equipment performance itself. And fourth, the process itself, the people. So the first shift operator comes in and says, hey, I have set up the best bottle possible. And then the second shift operator comes in and says, he touches the bottle and he's like, oh, that spot is just not right. I'm going to change it. So he's going to make a different bottle. So the 4 factors that are involved in making a bottle, the preform, the environmental condition, the machine itself, and the people making bottle are all sources of variation. And when RPET comes into picture, it actually exaggerates the problem. AGR has done a lot of analysis to say that if you have a virgin preform, the variance in material distribution is between 2 and 3%, but if it is an RPET preform, the variation jumps to 7 to 10%. That is a huge jump in the material distribution variance, in addition to all the factors we just talked about. So you could say, who cares about material distribution variance? What impact is that going to have on me and my company? There are 3 different issues that you will run into when you have material distribution variances in the bottle that you're producing. The first one is visual defects. You can have a choke neck, you can have a bent, a tilted bottle, you could have issues in the feet, you can have holes in the feet, things like that. So visual defects that you can see right away. The second issue, which is even harder, is going to be performance-related issues. So if you have a shelf life issue, that's not going to show up till it goes to the end customer, and the customer is going to open the bottle, and he is going to say there is no fizz in the bottle. This liquid does not taste exactly right because your shelf life was not what you were supposed to be. So you can have performance issues, or it can go down the palletizer and you can have bent pallets. Why? Because your top load was not exactly right. Those are issues that you do not see right away, but they are going to happen in the future. Third is productivity losses. So when you have material distribution variances, think about that picture that we just saw, where after the blow molder is going to go into the filler, the packer, the labeler, the palletizer. It goes in there, and when you have all these various types of bottles being produced, the way lines are set up is they leave it a little loose. So the conveyor, the airway is set up a little looser. Your star wheels are set up such that it can accommodate a lot of variation. When that happens, you start seeing a lot of jams. How many of you have seen jams in the airways? How many times have you seen line stoppages because the star wheel that goes right in front of the labeler is jammed? Those normally are not issues with the packer or the labeler or the airwayer. They are issues because the bottle that was produced had variances that was more than what that particular machine could take. So a lot of the issues and stoppages that happens in these lines are due to the process in which the bottle is made. So material distribution is something that we need to think about. It may not be visible right away, but those are causes for your efficiency reduction and your productivity losses. So what does that all add up to? When you look at all of those, they result in higher downtime, lower productivity, and lower efficiency. So the first thing, before you want to go into the digital space, is to say, what are the issues I see right now? How do I automate and do process control of certain things? And then talk about how do I take that data and truly utilize that data. Because if you do not have a good process control, the data that you have is going to be so corrupted with a lot of noise that the results that you're going to formulate from that data is not going to be good enough to move forward and make decisions. So when you think about Industry 4.0, when you think about digitalization, the first thing you need to think about is how do you reduce noise in your space so the data that you get actually is going to be good enough to make decisions to make efficiency improvements in the future. So you could say, hey, I've been in the blow molding space forever, and I know what I'm doing. Don't tell me what to do. That's fine. Let's see how things are being handled as of today. One, you could carefully select the preform sources. I saw a note in one of the blow mold lines that said, if the preform comes from this particular supplier, please do not run it on this line, because you will not be able to get a good bottle. So they manually track it. So if a preform comes from that source, it goes on this line. If a preform comes from this source, it goes on this line. Manual management of your preforms. People do that. We control the preform sources. Two, you can carefully set up your storage and utilization of preforms. So humidity controlled rooms are something that's very common. How much money do you spend on humidity controlled rooms? How much time and effort do you spend on FIFO? First in, first out. So when it comes in, it actually stays in the room for 3 days before it goes into the blow molder. Do not do the one that just came into the blow molder. How many times have you done that? That is another common way in which we do things. Three, you can put excess material in the preform. So you can say, hey, the ideal weight of this bottle is supposed to be 10 grams, but I am just going to put in 12 grams, so even if there's a material distribution variance, I do not have any customer complaints. That's a possibility, and that is something that has been done in the past. Next, a dedicated process person per line. You can say, I have a good process control team. So a person can be standing there, he can take care of all the variances, so I do not need an automated system. Fine, but is he going to be standing there 24/7? Is he not going to take a break? Is he not going to get sick? Think about it. You can have a support person per line. When jams occur, there's a person who's standing there to clear the jams. He can be sitting there. I saw one of those lines, it was this big, huge airway bend across the room, around the room. And there was a guy sitting in a chair, and he has a stick in his hand. And his purpose that day was to clear jams when a bottle gets stuck in that airway. And the quicker he does, the better he keeps the efficiency of the line. So yes, we can do that too. So when you look at all these ways in which blow molding and efficiency improvements are handled, what does it add up to? Cost. So if you truly want to think about automation, you not only have to think about the bottom line, but you also have to think about all the costs that you're expending today to make that process going, and that all needs to contribute into a return on investment as we think about long-term strategies. High-speed, repeated, consistent operation. When you have high-speed, repeated, consistent operation, you must think about automation. Otherwise, you will be left behind, and that's something that you want to think about. So, what is automation in a process control space? And automation, we said, has to be reducing manual operation and be able to do something more efficiently. So in the process control space, what we say is, you target or you baseline what a good bottle is. Then you measure the output of the bottle that you're performing. So you're making a new bottle and you measure that bottle. Compare that to the baseline bottle, and then decide what parameters do I have to change in the blowing machine to make a good bottle. So it's this continuous loop of making the bottle, measuring the bottle, comparing it to a good bottle, making changes, making the bottle. And that happening automatically, so no matter what the changes occur, be it variances in the preform, be it environmental condition, be it the performance of the machine itself, or be it the person doing the process, the system can automatically take care of some of those changes and be on guard 24/7. Process control is only effective when you measure the output to manage the machine. You cannot manage your input parameters to control what your closed loop is going to be. You have to measure what it produces to be able to control the machine. So this is the time when we start thinking about, okay, how do I do that? How do I truly get automated? How do I go digital? To get into that space when we are in a world where RPET causes variation, all our companies have sustainability goals, our resources are limited, but we need to maintain our efficiencies, we need to maintain our profits, and we need to maintain our brand image. AGR has a system that measures the material distribution, manages the process, and controls the flow motor automatically. We have more than 500 systems around the world, and it's been used in a lot of the leading companies to be able to manage the process as they look forward into an automated and a digital space. The advantages of process control, as we talked about before, is definitely reducing the material distribution variance so you can improve your efficiency, your pack rates, manage a higher turnover because it's reducing your labor utilization, and it improves your process. When you can manage some data, when you can measure something, you can manage it. And when you can manage it, you can control it. So that's where digitalization, automation, and efficiency all come in that same loop. As we look at Industry 4.0, we know that one, you need to have automation and process control so you reduce the noise. You collect that data, use that data efficiently so you can make decisions on what and how your efficiency and productivity can be improved so you can then go in a circle. If you do not do that, you could have so much noisy data that totally corrupts the decision-making process. So when you think about data, sometimes we're scared of data because, oh my goodness, I have tons and tons of data, I have no idea what to do with it. The first thing to do is to think about, is your data clean? To get clean data, you need to make sure that that process is stable. And that's where the automated process control comes in. And once you have a stable process, now you can start collecting data to make sure that you can make efficiency improvements and decisions based on that data. One of the things that we found was when we talked about the 7 to 10% increase in material distribution variances for RPETs, when automated process control was put in place, we were able to keep the material distribution variances in the output of the bottles produced to between 1 and 2%, no matter whether it's virgin material or RPET material. So this is just another example of where we were seeing a lot of variances in the RPET. When you have, this is going up and down the bottle, the material distribution measured up and down the bottle. When you have a virgin material, the variances is not very high, but when you have RPET, you have a lot of variances, and when you use automated process control, you can truly bring it down to a place where you don't have to worry about process control, but rather start looking into efficiency improvements. There's a couple of other places where we also see a big benefit of the process control space. The first one is when you see quick disturbances. So, for example, somebody just opened a big door that's right in front of your blow motor. A gust of air comes in. Your process has changed. You produce a different bottle. How quickly can I see that change and react to it? With process control, we were able to handle it 65% quicker than without process control. What that does is you're producing more consistent bottles. The other example is a startup. How many times have blow molders stopped and started and we say, okay, the first 5 minutes of my blow molding process, those bottles aren't good because the system is just getting up to speed with that heat parameters. So what we saw when you have automated process control is we see a 68% improvement in the reaction time, so you can get back into the baseline quickly. And what that element does is it reduces 30%, it has a 30% reduction in your rejects. So if you have a vision system or another measurement system, you can see a reduction of 30% during startup when you use automated process control. So when you talk about that, that is getting your material distribution, so you're producing a good bottle so you can keep your brand image. 2, you can improve your process so you can increase efficiencies. 3, you can make sure that your bottom line actually is better. So with the expectation to go green, with the need to make sure that you use your resources wisely, we have to embrace digitalization and automation and process control. Normal payback is around 6 months to a year, depending on where you start. Like Sid was saying, if you have a bigger goal and a bigger step to take, you do see a better ROI. So we talked about data. So we talked about this flow. One of the things that we need to talk about as we do digitalization is, 1, you have to have an automated process control so you reduce the noise, and then do a lot of data collection. So you can then look at the big picture, look at efficiency improvements, and where your next step needs to be with respect to improving your efficiencies. We have a lot of systems around the world. The other thing that I want you to think about, one is inline inspections and automated process control. But the other thing where digitalization really comes into picture is in the laboratory. A lot of times we do very manual measurements. So by the time you get bottles to the lab, you make all these measurements, production is going down at a high speed. How do you get to automate that to a point where you can get quick results, make the appropriate changes so you can move forward? So laboratory is something that you want to think about so you can get timely feedback so your production lines can be run efficiently. So there's a lot of systems related to dimensional measurements, related to pressure testing, related to thickness, that can be set up where you can do the measurements, no handwritten documentation, everything goes directly into your data collection system, so you can immediately see what the results and trends are in your production, so you can make appropriate decisions quickly. So we talked about predictive analytics. That is something that could only happen if you start collecting data and if you have a system that starts giving you trends to say, what is my trend? Am I going to go out of control very quickly? And if so, then what changes do I need to do today to make it better? There's one way of saying it, that's predictive analytics. The second one is targeted maintenance. If you see a trend in a particular machine going a certain way, then you can say, hey, you know what? For this week's downtime, I'm only going to target this particular aspect of my maintenance. So I can keep my maintenance time down and my uptime high. So targeted maintenance and predictive analytics is something that can occur if you make sure that your data is not corrupt and it is utilized well. So, as you look into the future, digitalization and automation will produce a very stable and predictive environment for you as you look ahead. The data, I know we're scared of data a lot of times, but if you start making sure that you have good data coming into your system, it gives us a way to get into the Industry 4.0 mode. And it can help you identify the bottlenecks and make sure that you make the right decisions to figure out what their efficiency goals need to be. So, are you ready to take a leap into automation? Industry 4.0 cannot occur without process control. So you need to first step into process control, make data your friend, so you can actually plan for Industry 4.0 as we look ahead. So the steps I would like for you to remember and take away from this discussion is focus on automation. Think about where you are. Think about what steps and what processes you can automate so you can actually move in the future. 2, make data your friend. I know data is sometimes scary, but make sure data becomes your friend. Make sure you collect the right set of data. Make sure you reduce noise in your data so the data is actually valuable and you can use it efficiently. Collect the data, decode it, implement the findings, reap the benefits, so you can actually improve the bottom line. So I know digitalization is scary sometimes, automation is scary sometimes, but this is the right time to start thinking about it, because without that, you will be left behind. So, thank you for your time.
Thank you very much, Sudha. So we now open the forum for any questions you might have. You want to ask Sudha?
You had mentioned trying to automate some of the testing that's currently done in the quality lab. Like, where do you see the biggest technical challenge there or opportunity?
Right now, I see a lot of labs where they're stuck to manual process. So, okay, you have a gauge, a caliper, and you're just measuring it, and it takes forever. So by the time the results come in, sometimes it's almost 4 hours, 8 hours before you get that set of results, a handwritten set of results, and then somebody has to input it into their system. So the biggest challenge that I do see is the change in the mindset. A change in the mindset where, as a company, we can embrace digitalization as a path forward. Because if it is left up to the different teams to do it and does not have a higher level of support, this is not going to get traction. Because they could be in their own little bubble saying, this is my world, this is my status quo, this is how I've done it, and this works for me. But they're not thinking about the future. That is where the management support comes in. I know Sid mentioned that too, where the first tier is the strategy of the company. What is your strategy towards the future? And then that gets rolled into the different departments. It's a top-down support, but it's also a bottom-up approach to what steps you need to take to get to that goal. So kind of merging those two is where I see the biggest issue. So companies that have truly embraced that from a strategical point of view were much easier to incorporate that into their process than companies at a high level have said, you know what, you guys want to figure this out yourself. And then there's a very distributed view of how things are, and there's no way to combine all that data and make it viable. But there definitely are tools and systems out there to get us into that process of doing it. But the question is going to be, as a top-level management, are you willing to embrace and kind of give a supporting hand to your team so we can all move together in that front?
Sudha, you mentioned the process control for the blow mold. For the blow molder, how about the process control for the preform manufacturing? Do you do anything on that front?
Nothing as of now. The factors in there, I mean, anything is possible. That is another thing that we have always looked into. And if there is a partnership or willingness to be talking about it, that's something that we can always do. But at this point in time, there's really not a process control system in that space.
Can you talk a little bit about the sensors and the way you're gathering this data? We didn't really discuss the technical aspects, but how is AGR doing that? And part two of that, is it only on clear packaging applicable?
So to answer the first question, what we found is the thickness measurements of the bottle is a very, very clear indicator of the performance of the bottle. So what AGR does is has a patented system to measure the thickness of the bottle from top to bottom, and we use that information to control the process. It is an online measurement system. So it acts on two fronts. The first one is every bottle gets measured to see what the thickness is, and it could be compared to what it needs to be, what your nominal control and reject limits need to be. So as a measurement system, it can measure and reject if needed, so no bad bottle goes down the line. But then second, it uses that data to collectively understand where the process drifts are, so it can then figure out what the lamp changes need to be, what the pre-blow changes need to be, and the preform temperature set point changes need to be.
Is it vision-based? How do you measure it? What's the sense?
It's infrared technology to measure thickness. Second question, is it only clear bottles? No. It's PET bottles, definitely. But all different colors, shades of it, as long as infrared light sensing can go into that bottle. We have seen cases where certain additives block infrared light and then we can't do it. But as long as infrared can be used to measure the thickness of it, it can be done. Polyolefin, case by case. Depends on the additives and material that's used for it.
All the machines adaptable, all the pilot adaptable to all the machine, and if one undertake this, what kind of review?
So the payback, I'll start with that. The payback is normally, if I have to be truly honest, I'll say it depends, but normally it's between 6 months to 2 years, depending on where your starting point is. So if your starting point is, oh, I'm at an efficiency of 99% and I want to get 0.5% efficiency improvement, you may see a longer payback. But maybe that step change is going to be a big investment based on your speeds. But if you start with the 60% and then you have to go to 90%, yeah, your return on investment is going to be high. If you go from 15 grams to 10 grams, your investment is your ROI is going to be much quicker, rather than going from 7.8 grams to 6.9 grams. But yeah, it's going to be dependent on that. So ROI, I would suggest stay like it's anywhere between 6 months to 2 years, depending on where your starting point is. But I do, in that ROI calculation, want you guys to consider, what are your current spends on it? How are you investing in, like what are you spending right now on an OpEx basis that could be converted into CapEx and OpEx eliminated? So is another way of thinking about it, because a lot of times when you do return on investment, you don't take all the costs into consideration for the ones that you're eliminating. So that's one thing. So normally 6 months to 2 years. And then as far as the blow molders go, we do operate in all the different blow molders. At this point in time, we have systems into Sudals, Crohn's, KHS, CEPAs, Teclons, everything, all different vintages. Any blow molder that has digital controls. So Series 1 blow molders for Sudal that has manual controls cannot be automated. That goes into the legacy system mode. They have to be first integrated into systems that has a platform that you can do digitally, and then what you can go into the automation. Thank you, Dan.
Can you only measure symmetrically shaped bottles or also handle bottles?
Yes. As long as the bottles are flowing through the system consistently. It's a relative measurement where you say, this is my baseline, this is my variance, this is my change. It's good enough. So the good thing of being inside the blow molder is when it comes out of the blow molder, the bottles are sent to the sensors exactly the same way every time.
We are asking this question because we are not in the stretch blow molding, we're extrusion blow molding, and extrusion blow molding of PET, so it would be of interest if that is possible with handle bottles, etc.
It can be, as long as the bottles are presented to the sensors in a consistent fashion. So if you have non-round bottles, the handles are always facing the same way and it's going on the conveyor the same way and the sensors are set up around it, yes. Because inconsistencies in measurement, so you can't send a bottle with a handle in the front the first time and a handle in the back the next time. Yes, as long as the bottles are oriented right, the way the system works is it takes a baseline of the current process, whatever that may be, and then compares the new process, measures the variance, and then figures out what the changes need to be. So it's less about absolute measurements as much as relative measurements to do process control.
Those measurements will be on one plane, not circumferential.
It'll be on one plane. And normally what we suggest is that plane be along the long axis of the body. So you have the measurements.
Any other questions? All right, so Sudha, I would like to thank you on behalf of the Jebadurai division for your time and participation. And guys, we will have a 15-minute break and